Hi everyone. We're going to be starting the new unit today, so it's going to be called Organic Chemistry. I think some of you will actually really like this unit, so it's kind of too bad it'll be a little shorter than normal, but we'll do what we can. Okay, so organic chemistry includes all compounds of carbon except for the oxides, carbohydrates, cyanides, and carbides. That won't make a lot of sense to you guys, so don't worry too much about that. Organic materials include foods, fuels, fabrics, woods, drugs, perfumes, explosives. We tend to think of organic now, like when you heard the word organic, you probably think things that are natural, etc., etc. We don't use chemicals on them, and that's one definition. But from a chemical point of view, organic means that it usually came from things that were alive, so organic material, and it includes all of these things here. Now you've got a chart here in your notes. You'll see organic chem, and then it's broken up into two different sections. So the area that we are going to look at, we're only going to look at the one branch here. So this is hydrocarbons. And then from there, that we have two different groups. So we have what's called the aromatics. So aromatics, and this side over here is called the aliphatics. Now within the aliphatics, so the aliphatic groups, we've got three different types. So we've got alkanes, alkenes, and alkynes. And these are just different bond types. So the alkanes are a single bond, alkenes double, alkynes have a triple bond. Today we're actually going to be looking at the alkanes. Now aromatics, on the other hand, these ones are in a ring, and so they're actually in little hexagons, but we'll talk more about that when we get there. So now carbon has 4 valence electrons. So valence, if you think back to your grade 9 science, you would have learned that these are outer electrons. So in their outermost shell, carbon has 4 valence. So what that looks like then, you've got a carbon atom. So in its first shell, it's going to have 2. And then in its outer shell, it's going to have 4. 1, 2, 3, 4. That means, and remember we draw on Bohr models, this means that carbon needs 4 more electrons to become stable, and this is called the octet rule. So we need 4 more electrons for it to be stable here. Because of that, we know that carbon can form covalent bonds then with hydrogen to achieve stability. So what that means, we've got a carbon, it can bond 4 times. So if we use a hydrogen on either end, they're going to be stable. Now let's just look at the carbon. So we know carbon, for example, has 4 valence, right? So I'll do those in red. Hydrogen has 1 valence as well. So the hydrogen is also going to be contributing 1 carbon each. So if you look here, now if I look at it, that carbon atom has how many electrons around it? Yeah, there's 8 electrons around that carbon because it's sharing with 4 different hydrogens. So the carbon's happy. Hydrogen is also happy because the hydrogen now has 2 valence electrons. So, and of course hydrogen only has 1 outer shell, so it only has 2 outer electrons enough to make its shell full and make it happy. Okay, now we're just going to go through some common examples here. So when we have 1 carbon, just so you know, this would be called methane. Now we have something called the structural formula and molecular formula. So molecular formula would be what we're used to seeing. So that would be 1 carbon, 4 hydrogen. So we'd write it like that, CH4. Now the structural formula is when we draw it out. So if you look here, carbon's going to have 4 hydrogens all the way around. So that's the structural formula. 2 carbons is called ethane. And so now for the molecular, or let's do the structural formula first. So we've got 2 carbons in a row. Now each carbon can make 4 bonds. So if we look at this first carbon here, we're going to have 1, 2, 3, and that line between the 2 carbons counts as a bond. So that first carbon now has 4. So we're going to put hydrogens all the way around it. And now this other carbon also has hydrogens around it. So now this would be my structural formula. The molecular formula, I'm just going to count up C2. So I've got 2 carbons, and if I add them up, I end up with 6 hydrogens. Now, for 3 carbons, oh, you know what? I should actually note too, there's different markings for this. So you could actually, if we look here, we can kind of break this up, right? So we've got 2 of these. So another way of writing that would be CH3, CH3, okay? Okay, now back. Now, for 3 carbons, you're going to draw 3 carbons in a row, 1, 2, 3. And then you're just going to fill in the hydrogen. So this first carbon has 3 hydrogens. The second one only has 2 because it's already got 2 bonds coming from the other carbon. And then the last one here, again, 3 hydrogens. And if we were to write this out under the molecular formula, C3H8. Now, if I want to write it using this kind of notation here, that's going to be CH3, and then CH2, and then CH3. Okay, so those are different ways of noting it. These are all the same things, just different ways of writing it. And I forgot to tell you the name here. This one is called propane here. All right. Now, we're going to start off learning about the aliphatics. So the aliphatic hydrocarbons. The word aliphatic indicates that these are in chains. So there's no rings, no circles, they're just in chains. So our carbons are going to be in a long line. So alkanes is where we're going to start. So alkanes, so chains of carbon atoms with single bonds only. That means you will only ever see one line like that, meaning the single bond. Now, these are saturated, so you can highlight that. These are saturated, alkanes are saturated, and that means that they've only got single bonds. So make sure you make a note of that. The general formula is going to be CnH2n plus 2. So for example, say you had 50 carbons. How many hydrogens would you have? So n is going to be 50. So 2n plus 2 would be 2 times 50 is 100 plus 2 is 102. If you had 100 carbons, how many hydrogens would you have? And it would be 202 because 2 times 100, 200 plus 2. So you're just going to have to learn that formula. That's what you use. Now, the prefix depends on the number of carbon atoms in the chain. And we'll do that in a second, actually. All alkanes end in ane, so that's one thing to make note of. Now, if you look back at what we did before, you'll notice, so these are all alkanes, but, whoops, hold on. But we've got all 3 of them end in ane, but they've got different prefixes, so meth, eth, prop. So we are going to learn those here. So if we look here, sorry, I'm just recording a video. If we look here, 1 is going to be meth, 2 is eth, 3 is prop, 4 bute, 5 is pent, 6 hex, 7 is hept. People often think it's sept, like in French, but it's hept. 8 oct, 9 is nona, and 10 is dec. Okay, we're not going to go any further than that. We're going to stop at 10 there. Okay, so you're going to have to well, because yours is open book, I guess you won't have to memorize it, but normally I would say memorize those, and you will naturally because we use them a fair bit. Now, branched alkanes. So groups called radicals sometimes connect to a carbon chain. So as an example here, so I'm just going to draw one out here. So we've got carbon. Let's draw this one out here. So if we look, all single bonds, so I know it's an alkane. And if I look here, I've got 3 carbons in a row, 1, 2, 3, and the prefix for 3 is prop. So it's going to be called propane. So my question is, or what you need to consider is when one of these has something other than a hydrogen. So let's take that hydrogen off, and instead we are going to put another carbon. And I'm going to put 3 hydrogens around it, okay? So now this is what's known as a branched alkane. So we still have our parent chain here, but now we've got this thing coming off of it, and this is what's known as a radical, okay? And we name radicals based on how many carbons they have in them. So this particular one has 1 carbon. So again, the prefix for 1 is meth. So this CH3 is known as methyl. If we had a carbon chain of 2 here, it would be ethyl. 3 is propyl, and we would just continue on: butyl, pentyl, hexyl, heptyl, etc., etc. Okay. Now, when we name them, these are just the rules. We're really going to learn these by working through examples here. So, naming branched alkanes. You're going to find the longest continuous chain and name it. Then you're going to number the carbon chain from the closest end to where the radical is attached. Then you're going to identify what radical it is, use prefixes, di, tri, tetra, etc. to indicate the number of radicals of each type present. You're going to use the numbered position to indicate where the radicals are joined, and you're going to list multiple radicals alphabetically. So ethyl comes before methyl, for example. One thing to note, if you have diethyl, one of the prefixes there, this would count as an E placement, not a D, okay? These rules will make sense as we go through here. Okay, so did I make it look fun? Does putting the let's play here, let's play name the alkanes, make it look like it's a fun time? I hope so. We're gonna go through some examples. You're gonna have to write these out in your books here. Sorry, I'm just finding my notes here. Okay, so we're gonna start naming them first. So I am going to draw it out for you, and then we're gonna name it together. I'm going to use a little, like the shorthand notation, because it's a pain having to draw all those carbons with the hydrogens. So I've got a CH3 bonded to a CH2, CH, and CH3, and this one is going to have a CH3 coming off of it. Now, I'm going to use red here. Okay, your first step, find the longest continuous carbon chain and name it. So what is the longest continuous carbon chain? So here's what you do. You can go 1, 2, 3, 4. You cannot go 1, 2, 3, 4, 5. So you can't go backwards like that, okay? Oh, damn. Sorry. You have to go, let me recopy this. So it has to be continuous. So my longest carbon chain is going to be 4 in a row. So 1, 2, 3, 4, moving across there. The prefix for 4 is but. The ending is always going to be ane, right? So butane is my parent chain. Now, next rule. Number the carbon chain from the closest end to where the radical is attached. So this is the radical. I like to circle my radicals. That is my radical, so am I going to start numbering from the left side or the right side? Yeah, and it's going to be the right side. So 1, 2, 3, 4. So I've got 4 carbons in a row. My numbering from the right to the left. What's my next step? Identify the radical. Okay, I've got one carbon here. So one carbon as a radical is going to be called methyl. So that is a methyl group. Use prefixes. Now we only have one, so I don't need to worry about that. You're going to use the numbered position to indicate where the radicals are joined. So if you'll note, this radical is on carbon number 2. So this tells me that the name of this molecule is 2-methyl butane. Okay, so one thing to note, you always have to have a dash between numbers and letters, okay? So there's always going to be a dash there. So 2-methyl butane is the name of this molecule. All right, we're gonna do another one. Okay, so this one I've got a CH3, a CH, a CH2, a CH3, and a CH2, and a CH3. Okay, so this is my molecule. So you're going to first determine what is the longest chain. So looking through it, what is the longest continuous chain? So the continuous chains, here people always get tricked, because if I asked you this in class, you would probably say 1, 2, 3, 4, because this one's 1, 2, 3, right? You'd be wrong, because chains can bend. They just have to be continuous, which means you can't go backwards. But what we can do is we can go 1, 2, 3, 4, 5. So 5 is my chain. This one is my radical. Now, so that means that my parent chain, pentane. So that's 5 carbons in a row. Now I have to number, so I'm going to look for the lowest numbering combination. So I'm going to look at this radical and think, well, if I start from the bottom, I'm going 1, 2, 3. If I start from over here, I'm going 1, 2, 3. So they're both the same. So it doesn't actually matter where I start from. So let's go back. So I'm going to start numbering here. So 1, 2, 3, 4, 5. That's a 3 there. So this is a methyl group. Again, I've got one carbon there. So the name of this molecule, 3-methylpentane. So that is the molecule. Okay, now next. Okay, so I've got a CH3, CH, CH2, CH3, CH, CH3, and a CH3. Okay, so let's look at this one. So I look here, again, first step, find the longest continuous chain. So try and do that. Yeah, so your longest continuous chain, you gotta do all the different categories. You go 1, 2, 3, 4. That's not gonna be it. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Yeah, either one of those work. So 5 is our longest, or it's our parent chain. Those are the 2 radicals. So now I need to figure out, where do I start numbering from? If I start from the bottom, which is down here, it's going to go 1, 2, 3, 4. So 3 and 4 would be where my radicals are. If I start from the side here, it's going to be 1, 2, 3. So I want to choose that one, because you're always going to look for the lowest numbering combinations. So I'm going to go ahead and number these 1, 2, 3, 4, 5. So I've got 2 methyl groups here. Both of these are methyls. And so because I've got 2 of them, and now I have to use those prefixes, the di. So the name of this is going to be 2. Now I have to indicate that they're on both those positions. So I have one on number 2 and one on number 3. So 2, 3. So you put commas between numbers, dashes between numbers and letters. So 2, 3. I've got 2 methyl groups. So dimethyl. And then my parent chain is 5, so 2, 3 dimethylpentane. Okay, so that is the name of that molecule. And we will do one more example here. back to blue. So CH3, CH, CH3, CH, oh, you know what? Hold on. I'm going to take that out. I should do that. Okay, I'm going to put this up here. Okay, so copy this one out. So looking at this here, okay, you need to figure out what your longest chain is. So you're gonna just start counting, right? So I go back to red. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They're the same, so it doesn't matter. So I'm going to make these my radicals here. Now these, I'm going to start numbering now from the end that's closest to where the radicals are. So I'm going to start from the left side because that gives me lower numbering combinations. So 1, 2, 3, 4, 5, 6. So that means my main chain or my parent chain is hexane. Okay, so looking at this is hexane. Now I'm going to look at the radicals. So I've got, this is a methyl group. This is also a methyl group because there's one carbon. This one here has 2 carbons. So this one is going to be an ethyl group. Now, we've got an ethyl group here, 2 methyl groups. So we have to name this appropriately. Now, you've got things on carbon number 2 and carbon number 4. You've got radicals on carbon 2 and carbon 4. You are going to name ethyl first because E comes before M. So you have to look at the alphabetical side of that. So the name of this is going to be 4-ethyl dash. Now I have to name the methyl groups. Now I've got 2 of them. They're both on carbon number 2. So you're going to go 2, 2. So you have to indicate both of them there. Dash, again, there's a dash. So 2, 2 dash, and then dimethyl. And then 6 carbons in a row, hexane. So 4-ethyl 2,2-dimethyl hexane. See, after we're done this, you guys, you'll know all those ingredient lists, all those weird looking chemical names. This is all they mean. Okay, now let's play draw the alkane. So you have to be able to do the opposite of that too. So instead of naming them, we also need to be able to draw them. So let's work through an example. So for this one, let's do 3-methyl heptane. So right away, you want to look to the parent chain. So you want to look at this. So this is heptane. Hept is 7. So right away, I'm just going to draw 7 carbons out. 1, 2, 3, 4, 5, 6, 7. Okay, I've drawn 7 carbons. Next, I'm going to look, okay, where are my radicals? Well, it says on the 3rd carbon, there's a methyl group. So I'm going to count 1, 2, 3. So a methyl group here. So a methyl group is CH3. So I'm just going to put that in there. Now, just erase that. Now, I'm just going to add my hydrogens. Now, you could have started from the other end. So you could have actually put the methyl group on this one here, because that would also be the 3rd carbon, but I just usually start from the left, but it doesn't matter. You can start from the right if you'd rather. Now, looking at this, you have to put your hydrogens in now. Oh, one other thing I meant to say. Does it matter if I write this methyl group on the bottom or the top? Because I also could have had it coming up to the top. Does it matter? No, it does not matter. You can choose which one you'd rather have, okay? So it doesn't matter. Okay, so looking through this, now I have to add my hydrogens. So you have to remember that each of these carbons makes 4 bonds. So this carbon here, if I look at number 1 here, so this carbon over here, it's already made 1 bond, which means it only has room for 3 hydrogens. This carbon now, the second one, has already made 2 bonds because it's bonded to 2 other carbons, which means it only has room for 2 hydrogens. This carbon here that has the methyl group on it already has made 3 bonds, so it only has room for 1. And you just keep on going and just remember to count to 4. So carbon can only make 4 bonds. That's all it has room for. Okay, we'll do another example here. Okay, so for this one, let's do 4-ethyl dash 2,3 dimethyl octane. Okay, so looking at this, again, you're going to look at your octane, your parent chain first. 8 carbons in a row. 1, 2, 3, 4, 5, 6, 7, 8. Now that I've done that, I can start adding my radicals in. So on the 4th carbon, I'm going to do an ethyl group. So 1, 2, 3, 4. An ethyl group is 2 carbons in a row, right? So C and C. So I'm going to call those CH2 and CH3. Now on the 2nd carbon, I've got a methyl group. So a methyl group is CH3. And on the 3rd carbon, I also have a methyl group. So that goes on there. Now I'm going to fill in my hydrogens from here. The 1st carbon has only made 1 bond, so I'm going to add 3 hydrogens. This 2nd carbon has already made 3 bonds, so I only have room for 1 hydrogen, 1 hydrogen, 1 hydrogen, 2, 2, 2, and 3. And there you go. You're done that one. We'll just do one more example here, I think. So this one, let's go, 3,3 dash dimethyl pentane. So looking at this one, pentane is the parent. So 1, 2, 3, 4, 5. Now, I look at the radicals. They're both on carbon number 3, and I've got, that di tells me that I've got 2 methyl groups. So you're going to put 1 going up, 1 going down. And then you just fill everything in. So H3, H2. Now this one, people get tricked here because if I look at this carbon here that has the 2 radicals on it, it's already made 4 bonds, right? So 1, 2, 3, 4. So it does not have room for a hydrogen, so you just leave it. This one has room for 2. This one has room for 3. And that would be how I would draw this out. All right. Now, there are some alternative notations that you have to get used to. So we've already talked about this. So CH3 is a methyl group, and so that's fine. But then CH2, CH3 is what's known as an ethyl group, and sometimes you will see it, I'm just going to write it bigger here, C2H5. So just an abbreviated form, and as we move through this, you'll find yourself starting to use these just because it's faster. Propyl here is 3 carbons in a row here. So this, again, is going to be just C3H7. That's a propyl group, and then you could just go up from there too. Now, for alkanes in general, this is another notation. Now, sometimes, like, you'll see this notation because it's hard to type organic chemicals or organic molecules. So you'll see them written like this. And what this means is that this CH3 that's in brackets, it is a radical on the prior carbon. So if we were to recopy this, it would be CH3, CH, and then I would take this and I would put it on the prior one, and then a CH3. So that's what that one would be. Over here, when I've got 2 in a row, I've got two radicals in brackets in a row. One's going to go on the bottom, one's going to go on the top. So that's going to be equal to this. So one's on the bottom, or top I should say, one's on the bottom, one's on the top. So these molecules are equal to each other. So that is that kind of notation that you also have to get used to. All right. Now, you can now do worksheet 1. So hopefully you've either printed off or picked it up from the school. So worksheet number 1 is now assigned. Don't worry about the stuff that says about isomers, though. We're going to learn about that. Oops, Isomers. We're going to learn about that tomorrow in the next lesson. Just so you know, these are the functional groups in organic chemistry. So there's a whole bunch of them. So we just covered alkanes. So that was just the very first one. And we won't do a whole lot of these in this class. A lot of these you'll have to wait till you get to university. If you take organic in second year university is where you would take that. But anyways, we're just going to start on the alkanes. Now I'm giving you the answer key so that you know right away if you're going wrong or doing things wrong. So you need to catch it fairly quickly, right? So you can figure that out. Okay, that's